I am super pleased to introduce our first speaker tonight. Rami Abou Ghanem is an engineer on the material design team here at Google. He hails from Canada, but is happy to call New York City his home for the past 4 years. He's going to tell us all about the brand new Flutter Gallery they just announced at Flutter Interact. So let's give a big, warm Flutter NYC welcome to Rami.
All right. Hello, everybody. I'm Rami. I am an engineer here at Google on the Flutter Material Design team. And I'm going to be talking about the new Flutter Gallery that we just released last month at Flutter Interact. So just a high-level agenda here. I'm going to talk about adaptive layouts, accessibility, and internationalization, and how we incorporated these into the new gallery. So just to kind of backtrack a little bit, as you saw at Flutter Interact, presumably, Flutter is now focused on more than just mobile. It also includes desktop, web, support, and so we wanted the new gallery to basically showcase that. So back in 2017, Flutter launched with this old gallery, what we like to call version 0. We didn't have any design input, and we just kind of put it together to showcase different widgets and demos for Flutter. And then for Google I/O 2018, we redesigned it with design input, and that's what many of you are familiar with, and that's what exists in the Flutter repository today. But we noticed something when we ran it on desktop. You get this, a blown-up phone app where nothing has actually been designed with the larger screens in mind. So we wanted to take a new approach and redesign the gallery. And we decided to do a full rebuild from scratch just because this was a good opportunity for us to not only showcase desktop-sized design, but also demonstrate some of the capabilities that you wouldn't normally think of, such as accessibility and internationalization. So in order to build this new Flutter gallery, we wanted to look beautiful, and we reached out to this design firm in London called Toaster, and we tasked them with redesigning the gallery app from scratch. But we gave them some parameters, obviously, like we wanted to keep most of the functionality from the old gallery. And they basically asked us, so what should the app look like? One idea they floated was, should it be Google branded and Material branded? And we told them that that didn't really make much sense since Flutter is an open source project. It doesn't really need to showcase Google's branding. Additionally, you've got the Cupertino widgets, which have nothing to do with material design and are a core part of the Flutter framework. Additionally, as you know, the material library within Flutter has its own section within the app, so it makes sense that the overall gallery app doesn't necessarily have to be limited to material design. Basically, we wanted the gallery to show off all the UI APIs that exist in Flutter, and what that meant was let the designers work outside any design system. Build something beautiful from scratch and have it be visually pleasing. So here's what they came up with. You see the old gallery on the left there and the new one on the right. This is what the mobile layout looks like, and here's where you start to see some bigger changes, the desktop layout. You can see that it's more information dense, you can see a lot of things all at once, and you don't have to scroll around or expand things to get access to all of the pieces of the application. So I'm just going to give you guys a quick demo of the new gallery, if I can drag it over here. All right, so here it is running on Flutter for Web. You've got the component demos down here, you've got our material case studies up here, you've got the application settings here, and if I can move my mouse, there we go. It's responsive, yeah. We bring the window size down, it's responsive, you've got a mobile layout, and everything works as you'd expect. You can see that we've applied the same thing to some of our material studies here. The design is responsive, and that giant text field demo that I showed earlier now looks like this, where we take advantage of the extra space to give you a little bit more information about the demo, including the code that is used to generate that demo. So the key focus for this redesign and rebuild: keep the existing features of the gallery. what that meant was all the material studies, Shrine, Rally, and Crane. These are studies that the material design team came up with 2 years ago as a way to showcase material theming and how customizable and flexible material is, and we wanted to keep those in the gallery. Additionally, we wanted to keep all the component demos so that users of the gallery can see what material and Cupertino components we offer. New features we wanted to build: adaptive or responsive layout, built-in accessibility support, and internationalization and localization. And lastly, providing more information in each component demo, including code samples and information about what that component is. So let's talk a little bit about adaptive layout and how we went about that. So we wanted to showcase materials flexibility for adaptive UIs. Additionally, we realized and recognized that there are many tutorials online, YouTube videos, Medium articles about how to build a responsive Flutter app. And while many of those are great, we also wanted to kind of put our voice out there too and showcase what we think are best practices. You don't necessarily have to agree with them, but they're out there for the world to see. We also chose to narrow our scope to just mobile and desktop. Initially, we thought about including tablet in there, but just for the sake of time, we just chose those two, especially since tablet and desktop have a lot of overlap a lot of times. That's not to say that we won't expand that going forward as we continue to work on the gallery. And we also wanted to basically build out those material studies with the desktop layouts that were already designed 2 years ago. Since we had the design and the specification for them, we figured why not build them out to showcase responsive layouts in Flutter. So here you can see a little bit of a code snippet on how we did that responsive layout. We basically defined an enum that included desktop and mobile and could be expanded in the future to include tablet or watch. And the key focus here is using the media query to pull up the size of the display. And what we deemed as desktop was when the shortest side of the display is larger than 700 points. That's just what we defined as desktop. That doesn't have to be what you define as desktop. It obviously can vary based on what you're building. And lastly, we built ourselves a little convenience helper. Is display desktop, just returns a Boolean, and we sprinkle that throughout the application. So I'm just going to show you a few different use cases, or a few different usages of this API throughout the gallery. One way that we used it is as basically as an input to parameters for things like padding. Here you can see that in this case, we wanted to have different padding on the end of the widget depending on if it was desktop or not. The more common case, which we found, was returning entirely different widget hierarchies depending on if it was a desktop display or a mobile display. We found that this was useful all throughout the application. For example, the login screen of the Shrine study uses a different layout for desktop versus mobile. So let me just drag that demo back over. So if we go into Rally, let's go into Rally. You can see the login screen here has this top bar and a couple text fields and then a login button here. Now if we go into the mobile layout, the top bar disappears, you get the Rally logo here, and the login button is now a fingerprint icon. And then we dive in, this is what the mobile layout looks like with the tabs along the top for navigation, and the content is front and center. Now if we blow it back up to desktop, we've aligned the tabs along the left and given more room for the main content to spread itself out. And everything is more information dense and more readable. Additionally, you can see in the component demos on desktop, as I showed before, you've got a lot of room here, and then you shrink it down, and we take advantage of the mobile layout to kind of hide these pieces here because you don't necessarily need to see them at all times. Okay, next I'm going to talk about accessibility. For those who aren't too familiar with that, it means a lot of things, essentially. Making sure your app is accessible means applying certain practices so that anyone can use your app, whether they are low to no vision or they require just additional, like, for example, one of the more common cases is text size. On mobile devices, you can set, at the operating system level, you can set the text size to larger. And out of the box, your applications won't necessarily respond to that, so you have to make sure that your application adapts to that. So, a couple points that we made sure to address in our gallery app. First one is support for screen readers. Screen readers, on iOS it's called VoiceOver, and on Android it's called TalkBack. Basically a setting that you can turn on at the operating system level so that the device reads out what is currently on the screen and allows you to navigate the application without sight at all. So what this means for Flutter is making sure that everything has semantic labels, such that the screen reader knows what your little magnifying glass button is supposed to do. Also making semantic announcements when it makes sense, such as adding something to your shopping cart, you would make an announcement, item added to cart. And you can go one step further and include custom semantics for things like things that you custom painted, such as graphs and charts. And I'll talk a little bit more about that after this. As I had mentioned earlier, we wanted to include support for text scaling, and we did that by making sure we had a setting in the gallery app itself so that you could play around with it and test it out without having to tweak it at the operating system level. We also went one step further and tweaked the sizes of various containers in the app that had text in them so that at larger text scales, things weren't completely smushed together and causing a lot of truncation. And lastly, support for focus. And this is relatively new Flutter API, especially with the advent of Flutter for Web. And the main use case here is being able to navigate the entire application using just a physical keyboard and tabbing around. So that's something we also included in the new gallery. So one of the first things that we noticed was images in Flutter out of the box have a semantic label attached to them. And if you don't set it, it just reads it out as image. So obviously there are cases where you don't want your images to be included in the semantic tree, and that can easily be achieved by setting the exclude semantics to true on the image widget. For example, in this screenshot here, that logo in the top does not make much sense for the screen reader to read it out. It doesn't add any value to someone using a screen reader. Conversely, you may actually want semantic labels on your images. So all you do is set the semantic label property to whatever string you'd like, and then that image will be read out loud by the screen reader. So in this example, you can see those little images next to each location. You may want to describe those images so that the users know what they are scrolling through. As I mentioned, when it comes to text scaling, you might want to adjust the size of your UI based on that. So the text scale factor that the operating system is set to, you can read that out using the media query. So again, media query.ofcontext.textScaleFactor. Spits out a double, it's 1.0 by default, and then you can use that as a multiplier for your width. In our little example here, I made sure to clamp it so that you're not growing your width infinitely. As I mentioned before, semantics for custom paint. So in the Rally application, we have this chart along the top here. And if we had done nothing out of the box, it would just have skipped it when you're using the screen reader. But what we did is utilize the semantics builder callback, which is a property you can override when you create a custom paint class. And that allows you to return a list of custom painter semantics. And in this case, we defined the rect of each slice of the graph and a value. So the screen reader will read out that value. So I'm going to quickly demonstrate some of this stuff here. So from the app settings, as I mentioned, there is a text scaling setting. So let's set that to huge. As you can see, a lot of the UI adapted to that. Labels are bigger. Everything flows nicely. And let's dig into Shrine. So the login screen, buttons are bigger, text fields are bigger. And here you can see this side menu here is wider than it normally would be. And the same thing with this shopping cart. It's got a little bit of extra padding because we wanted to make sure that the text fit on the screen when you add items to your cart and it wasn't being truncated. Obviously this is not a perfect solution. You could have the strings in here could be much longer than this and you'd still have to wrap or truncate, and that's fine. You just gotta do the best you can. So here's the gallery running on my iPhone here. Now, if this works, so when you turn on VoiceOver.
VoiceOver on. Flutter Gallery. Back to gallery. Button.
Hopefully you guys can hear that.
Back. Button. Checking. Heading. $600. $588.31. $1,640.86.
So that's what I mean when I say custom semantics for the graph. You can see that it would highlight each section and a user would be able to know exactly what's on that graph. Additionally, here you can see an example of the custom image semantic labels.
VoiceOver on. Flutter. Chalet in a snowy landscape with evergreen trees. Aspen. United States. One stop. Tent in a field. Big Sur. United States. Non-stop. VoiceOver off.
So that's a demonstration of how you can utilize the semantic labels to improve the accessibility experience for your users. Okay, next I'm going to talk about internationalization. So internationalization, it's mostly what it comes down to is translating your application for multiple languages. So for the gallery, we wanted to showcase Flutter's capabilities for internationalizing applications. So our application out of the box provided translations for, I think, over 60 different languages. We utilized the Dart INTL library as well as the existing capabilities within Flutter to support localization. We ended up working with our internal translation team here at Google, and they're the ones who helped us. They're the ones who actually provided the translations for all these languages. We sent them our English strings. They sent back languages or strings in 60 languages. Additionally, you have to ensure that your application responds to RTL languages. RTL is short for right to left, so these are languages such as Arabic and Hebrew, where you don't necessarily want everything to be left aligned. So Flutter does have support for that. There are widgets and classes that allow you to declare your UI using start and end rather than left and right. And lastly, we wanted to ensure that accessibility worked well with our internationalization. So what this meant is those semantic labels I was talking about earlier, we made sure that we translated those too. So when it comes to setting parameters on either a padding widget or an align widget, traditionally you would see something like this, where you're setting your alignments or your padding based on left and right. Instead, what you can do is utilize the directional variance of these. So now you say bottom start instead of bottom left, and you say have the padding only be on the start instead of only on the left. Very easy to use these APIs, just got to remember that they exist. As far as localizing the semantics, here you can see there's an icon button, and icon buttons get their semantic label from the tooltip value, which is just a string parameter. And rather than just set it to a hard-coded string, we set it to a localized string. Pretty straightforward. Okay, so and again, like with text scaling, we also built in a setting for this because it's tedious to continue to go to your system settings and set the app to a language that you might not be able to read. So by default, it's set to your system. And I'm going to switch it over to Arabic just to demonstrate RTL support. So as you can see, the app is now fully translated in Arabic, and everything moved so that it is right to left, even the settings menu and the heading labels. there's some strings that don't necessarily make sense to translate. Material, Cupertino, they're the names of products or libraries, so we kept those in English. All right, so in summary, we've rebuilt the gallery from the ground up to take into account everything that I've just talked about. Adaptive layouts, they're becoming increasingly important. Flutter is expanding its support for desktop and web platforms, and it may make sense for your application to support a responsive layout. Building in support for accessibility is fairly easily achievable given the APIs that exist in Flutter today. And the biggest thing you can do is add support for text scaling and for screen readers. A good international experience can broaden the reach of your application. Not everyone in the world speaks English, and even if you're only targeting the American market, you can still benefit from providing translations for commonly spoken languages here in America. Lastly, anyone can check out and contribute to the new gallery. It is at github.com/flutter/samples. We're happy to take contributions, suggestions, even if you just want to download the code and play with it. All right, thank you. And here are some links if you want to check out the web version, install the Android version, or play around with the desktop versions. And that is it. Any questions?
Arabic translations, is only standard Arabic, or you have like other Arabic accents like?
Yeah, that's a good question. So,
Could you repeat the question?
oh, sorry, yeah. So the question was, for our Arabic translations, do we just have standard Arabic, or do we have other dialects or variants of it? So you can see here we have like Egyptian Arabic, Jordanian Arabic, Moroccan Arabic. As far as if they are actually different, I'm not too sure because I don't read Arabic, but I think our translators did a solid attempt, so yeah. Yeah.
In Flutter, is there something like Bootstrap kind of CSS thing? For example, Bootstrap comes with a responsive CSS itself, so when you minimize the screen, it becomes responsive.
I'm not. So the question was, does Flutter have something similar to Bootstrap where it becomes responsive kind of out of the box?
Because you had to write custom code.
Yeah.
To make it.
So I think that is the solution in Flutter, is you can take whatever approach you want and write your own custom code to handle it.
Okay.
Yeah.
So there is no automatic thing.
Not really, no. There's a layout builder widget, and that's another way to do it, where that will give you essentially like a callback when the size changes, and you can adjust your UI based on that. Yeah.
For making a choice between different platforms, for a design standpoint, does it make more sense to choose which platform you're on to identify the platform, or really just identify screen size? Would that be a better strategy?
So the question was, when making choices on how to design the application, you're saying, does it make sense to identify the platform or just the screen size?
Yeah, as far as like UI display, like do you
Yeah.
always have to constantly say, am I iOS, am I Android, am I desktop, or would you, if you're not interacting with the native layer much,
Yeah.
would it be to choose pixel over framework?
So the way we did it is we chose the pixel size over what actual operating system is running on. There are cases where you would want to make certain exceptions for iOS just to kind of fit in with what users expect on iOS. Where you'd want to use the Cupertino alerts when you're using alerts because iOS users expect those. There's an article on Material.io about platform differences between Android and iOS that I like to look at when I'm curious about this kind of stuff. But for the most part, just screen size is usually enough, especially if your application has its own kind of design identity. Then the operating system doesn't matter as much. Yeah.
What tools you could use for automated functional testing? Can you use like Emperor or Selenium or other tools which you usually would use for iOS or Android?
Okay. So the question was, what tools can you use for automated functional testing, such as Appium and Selenium? Off the top of my head, I don't know the answer to this question. I think I've used Appium in the past, and I'm not. Presumably it would work with Flutter because it just reads it piggybacks off of the semantic system of the device.
So you have to write like web tests, you still have to write iOS and Android test 7.
Maybe.
Flutter driver.
That's right. There's the Flutter driver library that allows you to do tests like that. Sorry, I totally forgot. But yeah.
Well, that's
Yes, the Flutter driver library does allow you to do that. Then you don't have to write separate web and Android and iOS tests. Yeah.
You can actually also write unit tests as well. So you can unit test your widgets. It's not like
unit testing is fairly straightforward in Flutter as well. Yeah.
So Flutter support for Mac is in Alpha.
Is it alpha? I think it's
Something like that.
Yes. Yes.
Do you have like any VTA on the Windows and Linux?
So Windows and Linux is there. You can use it. It's pre-alpha, I'd say. One thing that the Flutter team found is Mac OS is very close to iOS, so it was easier to get that operating system up to speed. Windows and Linux development is ongoing. The link that I had shown here on this releases link, you can download a Linux and Windows version of the application. I'm going to be honest, I didn't test it on those platforms, so yeah, maybe a little finicky. Yeah. Yeah.
Do you find that using media queries, like when you have different widgets, it's fine because you just do one widget or the other when you have different sizes. But when you're doing like different paddings, like when you have web, you have the media queries, you can do like inside the class, you have different properties with whatever. But with this, you have to do individual styles. If it's desktop, you do this. Do you find that
Yeah, so I guess, so the question, just to repeat it, do you find that using media query like too tedious? Is that what, essentially?
When it's not a widget.
When it's not a widget? Yeah, I can see that being the case. We did our best to kind of, if we noticed that was going to be a problem, we'd factor it out into separate widgets and just build that widget hierarchy so that we weren't repeating is display desktop a million different places, just kind of creating common widgets when it made sense. So. Anything else? Oh, sorry.
Also, on Material.io, when it shows like widgets, there's some that have like Flutter, iOS, Android, and web, and there's some that Flutter isn't on. Are we expecting to see almost all of the widgets on Material.io to catch up, or are there going to be separate things entirely?
Yeah, the ones that Flutter is not available for yet, they will eventually become available. I don't know exact dates or anything, but the goal is to make sure that Flutter offers the full set of material components. Yeah.
Question about the text scale factor thing.
Sure.
Media query. Does that tie into the dynamic text size of the OS? So if I go to my settings on iOS, that's what that is?
Yeah, that's exactly what that is. So if you bump up the dynamic text size on iOS, or I forget what it's called on Android, that value will be read from media query. Cool.
All right. Let's hear it for Rami, guys.
Thank you.